right, so if you guys could grab out for me your 4-5 worksheet, that was your most recent homework assignment. And 16, you should have gotten 56e to the 19th power. Number 16 is 56e to the 19th power. Number 17 is 18w to the 9th power. Number 19 is x to the 6th power. Number 20, 3y to the 16th power in your numerator, 5 in your denominator. 21, let's see, 3 s to the 7th power over 8. Here's the answer to 21. Number 24 is 3h to the 14th power in the numerator, dividing by 2. And then on the back, you had to do number 26. Number 26, let's see, you should have gotten 3x cubed, 3x to the 3rd power. Number 29 is 40. 30 is 11. 32 is 20. And 33 is 24. So of those, raise your hand if you've got any questions. So for question number 24, I'm noticing in my numerator I need to simplify. So I'm going to ignore the denominator for now. I'm going to multiply 6 times 7, and I get 42. And then h to the 11th power times h to the 6th power is going to be h, and then 11 plus 6 is 17. And then in my denominator, I still have that 28h to the 3rd power. Good. Once you simplify the numerator, now we want to simplify the fraction. So 42 and 28 can both be divided by 7. So 42 divided by 7 is 6. 28 divided by 7 is 4. Ooh, and then I'm noticing 6 and 4 are both divisible by 2. So I would get a 3 and a 2. And then for my variables, h to the 17th power divided by h to the 3rd power, 17 minus 3 gives me h to the 14th power in my numerator because I had more h's in the numerator. And then on the back, the question was about number 26. Now we talked right before I let you guys work on the homework. For area, you multiply the length by the width. So my length is 3x squared times by my width is just x right here. What is the power on that x if I don't have one? It's just a 1. So I get 3, and then what's x squared times x to the 1st power? Add the 2 and the 1 together, and you get x to the 3rd power. Any others you guys want me to go over? I'd like you guys to flip to your front cover sheet, please. And we spent a couple days on 4-5. I want you to reflect on how you feel about 4-5. And 4-5 was all about the product of powers and the quotient of powers. And put your pinky where it says 4-6. And we're going to read this out loud together. Ready? 4-6 says, I can apply 0 and negative exponents. So go ahead and shade in the see it there. In today's lesson, we're learning about what to do when we have an exponent of 0 and what to do when we have negative exponents. And then flip in your notes to 4, 6. So this beginning portion here, I want you guys to start noticing a pattern. If we have 2 raised to the 3rd power, 2 times 2 times 2 gives me 8. If I have 2 to the 2nd power, 2 times 2 gives me 4. If I have 2 to the 1st power, I just have 2. So what do you notice is happening along this right-hand column here? What happens as we go from 8 down to 4? We're dividing by 2. What happens as we go from 4 to 2? Divided by 2. So what I want you guys to do is fill in the next blank. Take that 2, divide it by 2. So filling in the next blank. So every time it's just getting cut in half. It's getting smaller and smaller. So what is 2 divided by 2? 2 divided by 2? 1, right? 2 divided by 2 is just 1. So I'm going to put a 1 on that line. Then, we're going to divide by 2 again, because I'm just reducing my power by 1. So what's 1 divided by 2? 1 divided by 2? Can you divide 1 by 2? No, so it's just a half. And then if I were to divide by 2 again, if I were to take a half and divide it in half, I would get 1/4. So when we're dealing with these positive exponents here, you guys see how we're getting whole numbers, right? When we're dealing with negative exponents, what are we getting for our answers? We're getting fractions, right? So down here, go ahead and decode negative exponent for me, please. And I'm going to do negative, and then exponent, negative exponent. And we're going to deal with our example first. So go ahead for your example. I want you guys to write 2 to the negative 2nd power. Now, we cannot actually evaluate negative exponents. It's not possible to evaluate a negative exponent. So what we have to do is actually rewrite this so that way it has a positive exponent. Well, I'm going to start by writing this as a fraction. And to write this as a fraction, it would just simply be 2 over 1. Or 2 to the negative 2nd power over 1. If I want this negative exponent here to become a positive exponent, what I have to do is take and move it down to my denominator. So when I move that 2 to the negative 2nd power into my denominator, I get 2 to the positive 2nd power. So moving that exponent from the numerator to the denominator turns it into a positive. But we still have something left in the numerator. It's not nothing, it's something. Anybody know what it is? Oh, you had a question? Okay, yeah, there's a 1 left in the numerator. Go ahead with your question. Now the value what is 2 squared? What's 2 times 2? 4. So we get 1/4 for our answer, which is what we got up here for this example. So down here, anytime you've got that negative exponent, you're going to take the negative exponent and its base, and you're going to move it to the denominator. So a to the negative nth power is going to move down to our denominator and become a to the nth power. And then what remains in the numerator? A 1. Yep. So we're going to flip to the back side and take a look at example 1. And we have to write these expressions using only positive exponents. So when we have a final answer in math, we don't want negatives in our exponents or in our power. We want to rewrite it so that we only have positive exponents. So here you can see I've got 5 to the negative 4th power. Since I have that negative exponent in my numerator, I'm going to take it and move it to my denominator. And when I move that to my denominator, it becomes 5 to the positive 4th power. It becomes 5 to the positive 4th power. And then what is remaining in the numerator? A 1, right? There's still a 1 left in that numerator. Yes, go ahead. It's not. It could be in the denominator as well. So if you had a fraction that was like this, 2 over 5 to the negative 4th power, if the negative were in the denominator, you would actually take it and move it up to the numerator. So it would become 2 times 5 to the positive 4th power. So you just move it to the other location. Now, if you take a look at this we do portion here, the one thing to keep in mind is you only have to move the negative exponents. So do you guys see how in this example here, that x to the 5th power, that's a positive 5th power? That stays. That does not move. But this y to the negative 11th power, because of that negative exponent, that piece is going to get moved to our denominator. So that x to the 5th power remains in the numerator because it's positive. We're going to move that y to the negative 11th power to our denominator, and it becomes y to the 11th power.